Hello students, today's lecture is based on operations on matrices. We will discuss three major operations on matrices. The first operation is addition of matrices. So if we have two matrices, matrix A of order m by n and matrix B of order m by n, then addition of matrices is represented this way: matrix A plus matrix B. This addition is first of all possible only when the order of the two matrices is exactly the same. So on adding these two, we get a matrix represented by this way of the same order m by n. For example, A is a matrix with elements 1, 2, 3, 4, 5, 6. The order of this matrix is 2 by 3. B is another matrix of same order. These are the elements of matrix B, order 2 by 3. Since the order of the two matrices is same, the addition will give us a matrix of the same order, and the addition is done by adding the corresponding elements. So 1 plus 4, 5, 2 plus 5, 7, 3 plus 6, 9. Likewise, adding these elements, 4 plus 1, 5 plus 0 and 6 plus 1. So you can see here the addition of matrices gives us the same order as was that of matrix A and matrix B. Now we will study properties of addition of matrices. So the first property is that matrix addition is commutative. Commutativity basically means that if we add matrix A and matrix B, both are of the same order, then this should be equal to the same as is obtained by adding matrix A to matrix B. So here the resultant matrix is suppose given by C. The order of matrix C is same as the order of matrix A and matrix B. So adding matrix B to matrix A and adding matrix A to matrix B gives us the same result. This result is known as commutativity of matrices. Then matrix addition is also associative. So if we have three matrices of the same order and we add matrix A and B first and add matrix C to it, this will give us the same result obtained on adding matrices B plus C first, which is added to matrix A. The resultant matrix that is obtained here is suppose matrix D, which is of the order m by n, which is same as the order of A, B and C matrix. Existence of additive identity. Now here additive identity is not a number. By additive identity here again we mean to say some matrix. So a matrix A of order m by n, what we exactly mean by the existence of additive identity is, to this matrix A of order m by n, something should be added to get back the same matrix. So what we should add here is a 0 matrix. So this is not the numeral 0, this is the 0 matrix, the English alphabet 0, the English alphabet O, and this 0 matrix is also of the same order m by n, which clearly indicates that addition is only possible when the two matrices have the same order. So this zero matrix is known as the additive identity matrix. Next is existence of inverse matrix or the inverse identity matrix. This means that a matrix A and matrix B of same orders are added to get the additive identity matrix. The additive identity matrix is of order m by n, hence order of matrices A and B is also m by n. So on adding two matrices, if a zero matrix is obtained, then matrix B is called the inverse matrix of matrix A. Going by simple mathematical expression here, we can clearly see that matrix B is basically equal to negative of A. So the equation can also be written as A plus B matrix, which is minus A, will give us the zero matrix. The next property is negative of a matrix. A matrix A of order m by n has a negative matrix represented by minus A, which is represented this way, of the same order m by n. What it basically means is, suppose we have a matrix of order 1 by 3. The negative matrix basically means replacing each element of the matrix by its additive identity. Additive identities of these elements are minus 1, minus 2, minus 3 of the same order 1 by 3. So here is matrix A and this is the negative of the matrix. The next operation we study is subtraction of matrices. So two matrices can again be subtracted if they have the same order. So matrix A of order m by n and matrix B of the same order m by n. So subtraction is represented this way, which means that matrix B is subtracted from matrix A and the resultant matrix is of the same order. So if matrix A is 1, 2, 3, 4 and matrix B has elements 5, 6, 7, 8, then A minus B is possible because A and B have the same order, and subtraction takes place by subtracting corresponding elements. So 1 minus 5, 2 minus 4, 3 minus 7, 4 minus 8. This is A minus B, and in case we want to find out B minus A, then we are subtracting elements of A, matrix A, from the corresponding elements of B. So that way 5 minus 1, 6 minus 2, 7 minus 3, 8 minus 4. So in general, for two matrices of same order, A minus B is not equal to matrix B minus A. The other operation is multiplication of a matrix by a scalar. Scalar basically means a non-zero real number. Suppose the scalar is represented by lambda. A is any matrix if it is multiplied by lambda, a non-zero scalar. That means each element of the matrix is multiplied by that non-zero constant. and the resultant matrix obtained is of the same order. For example, if matrix A is 1, 2, 3, 4, 5, 6 and lambda is suppose taken to be -2, then -2A will give a matrix of the same order 2 by 3 with each element being multiplied by -2. So the first two elements that ways would be -2, -4, -6. Second row elements -8, -10, -12. With these concepts of matrices, I'm going to take up some questions from exercise 3.2. Question number 1. Matrices A, B and C are given as square matrices. Matrix A, matrix B is 1, 3, -2, 5. Matrix C, -2, 5, 3, 4. So as you can see, there are three matrices of the same order, 2 by 2, and we have to find out here A plus B, A minus B, and 3 times A minus C. So matrix A, 2 plus 1, adding corresponding elements, 4 plus 3, 3 plus -2, 2 plus 5 gives us 3, 7, 1, 7. Likewise, A minus B means subtracting B matrix, elements of B matrix from corresponding elements of matrix A. So 2 minus 1, 4 minus 3, 3 minus -2, 2 minus 5 gives us a square matrix with elements 1, 1, 5, -3. 3 times A means multiplying each element of matrix A by 3, so we get 6, 3 into 4, 3 into 3, 3 into 2, minus matrix C with these elements. So it is again subtraction of corresponding elements. 6 minus -2, 9 minus 3, 12 minus 5, 6 minus 4 gives us a square matrix with elements 8, 7 in the first row, 6 and 2 in the next row. So in the next video, I'll be taking up multiplication of matrices.